What about now?
We can see.
Right. So this is the last things we have done in the previous lecture. We passed to the Babylonian ancient or decade, beginning over for 1,000 years ago. Years ago, the Babylonians were discovering how to use mathematics to perform functions of daily life and evolve as a dominant civilization. Since the beginning of the 1800s, about 500,000 Babylonian tablets have been discovered, fewer than 500 of which are mathematical in nature. Scholars translated these texts by the end of the 19th century. It is from these tablets that we gain an estimation for the Babylonians' evident understanding of mathematics and the manner in which they used some key mathematical concepts. Through these slides, we will provide background information about the Babylonians and then explain the manner in which the Babylonians used the number system, the square root of 2, Pythagorean mathematics, and equations. Right. Return now to the Babylonian numerals. The Babylonian numerals are shown in the following table. They were probably created using stylus against humide clay tablets. Here we mentioned the word stylus. Stylus, I will show you this in the picture. This is a stylus. I will share this stylus. What does it mean? Right. Uh, the photo is clear, yes?
Yes.
Right. This is the tool they were writing by. Okay? Stylus. Is it clear? And the
Yes, ma'am.
tablet we have mentioned, we call it tablet. As we have actually the tablet of that decade made by the clay. What does it mean, clay? I will show you the clay. What does it mean? This is the clay. Is it clear? Clay.
Yes, ma'am.
Okay, it's a matter they made by the tablets in that decade. Okay, let's follow. Okay. We started here with Babylon numerals. Uh, I will uh, I will let you 5 minutes to uh, to observe very well the numbers in that decade. Okay, 1, 2, 3, and so on. Just observe. Okay.
Okay.
Great. Let's turn to the next slide. The Babylonians used base 60. So we have here example. The number 2 here is the exponential, okay? Exponent. So 60 exponent 2 plus 34 multiplied by 60 plus 28. It's written as follows. To test this or to practice the numeral numbers of Babylonians, we will take an example. I will type the example in the box message. Wait. Okay, you have the number. Try to write this number in the Babylonian written. Go to the message box, okay? Have you received the example? In the
Yes,
box
ma'am.
message.
Yeah.
Okay. I need
Yeah.
I need this number in the Babylonian writing, okay? Right now. As I have noted here, the 2, it's not the multiplication of 60 with 2, no, it's exponent, okay? Now, this number, you can calculate it in our system. I think equal to the number shown in the screen in our system is 26,008. Okay, but in Babylonian written has shown here. I have corrected the mistake in the box message. Okay, try to look at the box message. So 7, it's the first letter here in Babylonian system. Here we have 13. Okay, the last one is 28. It's so easy. It's so easy. They have used the basis 60, as I have noted here. They have used the basis 60. So when you have a number, you must divide it by 36,000. Then you go to 60 and so on. You must write it as I have shown in the box message. 7 multiplied by 60 square plus 13 multiplied by 60 plus 28 multiplied by 60, we can say exponent of 0, which equal 1. Great. Anyone find the answer? Yes? For the number? Great. Yes, it's 2 multiplied by 60 square plus 5. That's all. But the important point here is how to write it in the Babylonian writing. Which number I will use here? Yeah, base 60, yeah. You have here the table in the screen. Which number I need to present this number? Look here, we have used 7, we have used 30, we have used here 28. In example, what we use?
2.
2 and 2 and what?
2 and 5.
Yes, 2 and 5. Just remark here, when we write this letter, we must to put in space between 2 and 5, because in the base 60 there is no number. Okay, so you must to put 2 in there. Is it clear in the screen? We write 2 then small space, then 5. Okay, to present this number in their system. Okay,
Okay.
let's follow. We turn now to the Akkadian tablet, which is available from or since 1700s before Christ. The screen is clear.
Yes.
Okay. In the paper one, with citation describes Babylonian mathematics. He begins with the tablet from 37,000 years ago. As shown in the next slide, there are 4 columns. You should satisfy yourself that this is table of ninths. We'll see how or why ninths. Note that in the base 60 we have 108 equal to 1 multiplied by 6 plus 48. I think it's clear now.
Yes.
Right? Book introduces a slash notation to write this as. So here the book used another notation, which is slash. He used just 1 and 48. Okay. Here's the table of ninths. Why we have said this ninths? Because we have the first columns, okay? The second one, like a first multiplied by 9, okay? Look here, you have 1 multiplied by 9, it will give us 9. 2 multiplied by 9, give us 18, and so on, okay? It's clear.
Madam.
Right? We turn now to the multiplication in that decade. Several multiplication tables have been found. Another method for multiplication relied on using tables of squares, such as shown in the following table. To multiply numbers, only the squares of the numbers needed to be known. How this? We have the multiplication of I and B equal to the sum of I square minus I square minus B square divided by 2. Or another method, you have to use another method, which is the sum of IAB square minus the subtraction of I and B square divided by 4. I think this is clear. Actually, we have used this, yes? So, in that decade, what you should have? You should have the square of the number. How this? The multiplication, no, the sum and the subtraction, it's normal use as we have actually. So, I plus B, when you have a number, you need to hit square, and the square of I and square of B. So, you do this calculation to have the multiplication of I and B. Let's turn to see the table of squares with Babylonian numerals in the left, this one, and slash notation in the right side, okay? This is square of the numbers in that decade. And this is notation of slash notation. Slash notation as I don't know its name. Book, yeah. This is notation. You can use it easily, this one, because you have the formula to apply it, okay? Reciprocals, Babylonians did not have division. Instead, they use tables of reciprocals. We think of the reciprocal x bar of x as the number such that x multiplied by x bar equal 1, as we have actually. Since the Babylonians did not have zeros or use decimal points, then 1 written in Babylon like so, 60 written like so, and 60 square like so. You see, remark here, have the same notation, okay? It's complicated. would all appear the same on a Clay tablet. This is the problem. Okay, this is base of 60 is not good because would all appear the same on the Clay tablet. So a reciprocal would actually satisfy x multiplied by x bar equal to 60 square or exponent to n, since 60 exponent to n look like 1. In the following table, we list a few reciprocals table. Here you have a reciprocal of some numbers. It's reciprocal written as follows, but this slash, it's not dividing, okay? It's a notation, this one. Okay? Addition, subtraction, and multiplication are performed as in our system, but remember the base is 60, so you carry and borrow based on 60. Multiplying the divided by the reciprocal of the divisor performs division. To simplify the division process, tables of reciprocal were used for those numbers that have a terminating 6 fraction. The Babylonians tried to avoid using fraction with non-terminating 6-decimal fractions like 1 divided by 7 and 1 divided by 11, etc. In the next table, the semicolons is used to separate whole numbers from the fractional part. Here you have several examples used in that decade to show you how the reciprocal written for each number. Here you have a small test. I need to show me how this result found. The reciprocal of 2, the reciprocal of 3, and so on. How they found these results. Okay? I need the answer for the next lesson. Okay? Do you understand me? Yes? Here you have the question is how they found this fraction. This fraction, how they found it, this one. 1 divided by 2, or the reciprocal of 2, it's 0, 13, or 30. The reciprocal of 3 is 0, 20. Reciprocal of 4 is 0, 15. How they found these results? Okay? Test. How the reciprocal So you have the results here, just to justify, okay? This is for the next lesson. We turn now to the Pythagorean triples. Pythagoras lives around 500 before Christ, but the story of the Pythagorean theorem begins long before that, at least as far back as 1800s before Christ in Babylonian. The evidence is a clay tablet known as Pempton 2200, which systematically lists a large number of integer pairs for IC, for which there is an integer b satisfying I square plus b square equal c square. Okay, this is a small note about the Pythagorean theorem. So they noted in the tablet in that decade that they have used Pythagorean, but not with the name Pythagorean, okay? Later they give her name as Pythagorean theorem, okay? This is a tablet where they cover this theorem. Lampton 302200. Okay, the last point in this decade, quadratic and cubic equations. The Babylonians were framed as constructors of tables which could be used to solve equations by constructing tables for n cubed plus n square. The following quadratic and cubic equations, respectively, could be solved. So in that decade, they have found how to solve the square and or quadratic and cubic equations. This one, square equation, quadratic equation, and cubic one. Here I want to give you a small survey. The Babylonians developed a sophisticated mathematical system by which they could determine the positive solutions of any quadratic equation and the roots of some cubic equations. Documents attest Babylonian methods for resolution of equations of higher degree than the second, as well as tables that provide the roots n of numbers written in the form n squared multiplied by n plus 1. Then they solve a direct cubic equation of the form. We have here the form of equation. It's not clear. I will show you the form. I'm typing the equation, okay? The third order in the box message. You can take a look on the box message to see the form of the equation of the third order. Okay. So we will stop here. Okay. In the next lecture, I will receive your test. Okay, small test. This test, and we will talk about the Egyptian mathematics, history of mathematics, and after that you will have group work. The other civilization, you will do it as work in groups. Okay, it will be the exam notes. Okay.
Okay.
Great. Okay. See you the next lecture. Salam.